Okay, I'm Hannes-Korte from Fraunhofer IAIS in St. Augustin, near Bonn. And maybe you wonder why you don't see Melanie Knapp here, because she was announced in advance. And yesterday she called me that she is not able to be here today, unfortunately. So that's why I stepped in for her. The title of the talk is The Meaning of Data. And I think it's mostly about textual data, because we have many relevant information stored in text. My background is I'm a text miner, an NLP scientist at the Fraunhofer Institute, and that's why the focus of the talk will be about information extraction from natural language text. And what it is the idea is we have many text information sources, like for example news articles, and we want to extract information from these articles. And we added a few I wish I knew questions to the slides to maybe just bootstrap some ideas to formulate your own ones. In this case it's I wish I knew again how I can automatically analyze the meaning of the news. And the good news is, up to a certain level, this is possible. So up to now we can, for example, classify news articles to understand that in this article it's about research and politics. We can find relevant phrases or phrases that belong together because they're mostly correlated in many texts. And we have natural named entity recognition, like the DARPA is an organization, Bonnie Dog is a person. We have currency symbols and money values, things like that. We have a summary or the most important block of the article, and we also have relations. Doesn't look really nice, but this is meant to be a relation here between the project and the goal of the project and what this goal is. So there are techniques to extract things like that, and up to a certain accuracy. So it's not perfect what we can do with machine learning in the natural language area. There are many business applications. They're highly dependent on these techniques for market intelligence, innovation management, competitive intelligence. You want to know what your competitors are doing, and in the optimal case, in real time or near real time. So if your competitor announces something, you want to know, you want to be informed and alerted in the very moment. You name it. There are many applications, and I think many of you even know better than I do what your applications are and how natural language processing can help you to understand better the text you want to analyze. There are many startups from the last years that tackle these problems in a very nice manner. There's, for example, there's Quid. I think it's a US startup, and they try to monitor technology. Whereas new technology rising, whereas trending topics in social media, like many do at the moment, in patents, in awards, in organization websites, and they all track all these sources all the time and visualize it in a really nice manner. Others, like Recorded Future, they analyze text from not from the history but from the last time, and so they try to predict events that may happen in the future. So they observed the time up to now, and they knew if there was one event we saw in the news, for example, 3 months ago, and now something is happening. Whatever, there's a new startup in a new area, something like that. And so And they try to predict, based on this data, what will happen in the future. And like you see here, this is the company network or the related companies and products for, I don't know what it is exactly, maybe Amazon is in the center of it. And they try to predict to the future which companies will be related to each other. And which events will happen. I don't know how accurate it is, but I think they really earn money with it, so it will be some really good value you can get from it. This is a project my colleagues implemented. It's a risk management for a large insurance company, and what you see on the map is the addresses of their customers and where the contracts are. That are the blue dots. And the red dots are newspaper articles where the topic is about fire in that area, and it's about fire insurance. So they just wanted to know where the local news mostly speak about fires and where the contracts are. So that's a risk for them, of course. And I think it was about just 2,000 RSS feeds were crawled regularly, and so it's not that big data Ted was talking about, but yeah, it always goes into that direction, and I think it will grow with the time, that the needs grow. That was B2B. Now we have B2C as well. We see text mining or NLP and things like Wavy, where you get personalized feeds about what's happening, what could be interesting for you personally, and yeah, it's about the signal to noise ratio. So the problem usually is, at least that's my problem with Twitter, for example. It's so much data that comes in to my Twitter account, and to how to filter out the things that are maybe not that interesting. So, for example, maybe you know that you follow somebody, and every fifth tweet is interesting for you, but the rest is like private stuff. The cat is sick or something, and you don't want to be informed about that, but maybe about some announcement of a conference or something. Yeah, that's about the signal to noise ratio. You want to filter out the noise, and that's what Wavy does very good. That we have other applications. We have Prismatic. It's about the same, I guess. I'm not that into these new startups, but I think it's about selecting relevant information for you, and even from other sources you didn't even know. So what they do is to get much information from many different sources and try to predict whether this information could be interesting for you, especially based on your Facebook likes and the interests of your friends and who you are following, which RSS feeds you are following. So based on this information, they try to predict which other information outside your channels you're following could be interesting for you. This is Quote. This is just a prototype we built in the last month. That's just nice. It was actually, we started with it just playing around. It was just an idea to extract quotes from persons from the newspaper press, and just to visualize it in a stream. So what comes in, what new quotes from celebrities, and that's interesting, because you really get an idea of what's happening today or what happened yesterday when you just open up this quote app and you just have a look at it. What's here in the first place? It's Franz Beckenbauer. Das Glück war diesmal auf der Seite von Chelsea. Okay, I think Chelsea was lucky. I think this information is a few weeks old, but you know what it's about. That's funny. And how does it work? There are several problems in natural language processing, and Some of them are older, some of them just raised in the last years. And one of them is the text classification. You already saw it's like sorted into the area of research and politics, what this article is about, and this is called classification. You can have like multi-class or single class, like multi-label, so that in this case it's multi-label. That means we have two labels, we have research and politics, both belonging to the same article. Yeah, I won't go that into detail. We can do this afterwards in the workshops then. We can have something like topic modeling, where you try to find semantically related words to each other. So that you can, that helps, for example, that could help you to do the classification task if you read an article and there's just written machine learning in it, but not unstructured data or text analytics, but you wanna have an NLP label on this article. Then you know after the topic modeling step that machine learning, unstructured data, and text analytics appear very often together in the same article, so it has to be related semantically somehow. So that helps you to classify it, even if the concrete words are not part of the article. You have named entity recognition. That's what I mentioned before. You have like Bonnie Doe as a person, or DAP as an organization, Department of Defense as an organization, and so on. Relation extraction, yeah, that's what I said. In this special case, it's just the goal of the project is the relation to the increase of the quality. So what is the goal of this project? And you can have the explicit phrases in the sentences here. Yeah, the evolution of these approaches is, yeah, it's really rough here. It's not. Yeah, you can try to sort it into these three ages. And the pre-2000, the pre-millennium age is like the back of words age, where everything started with the classification, and you just use the words you find in the content of a text article, and you throw them into a bag, and you lose the positions and the ordering of the words. It's just, there's a word like learning, and that's maybe a feature that stands for the NLP label for this article, for example, or research. But you don't know about the positions and everything. So with this approach, with this bag of words approach, you can never understand that there's a named entity, like a person name in the text, because you don't know the ordering of the words. So that doesn't really help you. Then you had the sequence age. It's like you still keep the sequence, and you try to get out of the sequence of the words. You get out some interesting features for your machine learning algorithms, and like conditional random fields in this case. There are many others, but I think that's the state of the art for sequence labeling. You use conditional random fields. The structure age is then you get in some more complex structure, not just words, not just a sequence, but a more complex structure, like, for example, parse trees, which can help you to understand relations in text. Parse trees is something from the linguistics, is you try to get a syntactical tree of the grammatics inside the sentence, so you have a subject and an object, and they relate to each other somehow. And that helps you to understand the relations, the semantic relations inside the sentences. Like Steve Ballmer is the CEO of Microsoft, something like that, and you have this CEO relation between Steve Ballmer and Microsoft. These things it can be done with parse trees very well, and that's up to now. And here we see again the island solution that's the name a colleague gave this age to. You had neural networks, rule-based linguistics in the old times, from up to 96, that's what he said. I mean, that was before I started working on this field, so that's just what they told me. Yeah, I was 16 at that time, so it was I wasn't really observing these research fields. Yeah, but you had very limited hardware resources at that time, so things like neural networks. Yeah, you weren't really able to apply these algorithms to large data, and but that has changed up to now. So now we see a revival of old methods. Like neural networks are called deep learning now, and for example, we saw the finite state transducers in Lucene. Maybe you attended the buzzwords, then you saw the talk about that. That's really a really old approach to these things, but now it's yeah, it's a revival with more modern hardware. You can do much more, and yeah, that's why it comes back. Another aspect for the yeah, it's called network age. So what it's now and maybe in the near future will be, everything is linked and everything is a graph. You don't have what I said before, the bag of words, which is really unstructured. You just have a set of words contained in the text. There's no real structure about that. And now you try to link everything together. You have relations between all the words. You have relations between the words in the text. Like for example, you try to resolve entities. You find like Bonnie Door in the text. We could try to match this Bonnie Door to an entry in the DBpedia or something, and from the DBpedia you can match some other sources. That's the linked open data world, and I think that's where we are now, and where we'll be in the even more in the future. So yeah, a few other questions to start up, like the discussions afterwards. I wish I knew how I can build domain-independent systems. So a domain is where you train your models on, is your domain. And if you leave this domain, you're not guaranteed that the accuracy of your system is well, or, yeah, behaves well in other domains. And that's what it's really complicated. And I wish I knew how I could build language-independent systems. So that's another hot topic. I think that you try to get yeah, convert the knowledge you have in one language to another language. And there are many current research projects going on in this direction. Yeah, finally, how can I visualize the data? That's a really interesting point. What you see here is, by the way, I think it's a topic model based on customer reviews about some, I think it's a Regensensor, I don't know the English word, it's a sensor for rain sensor probably, something, from a German company, a German car manufacturer. And here you see the grouped words. Maybe you can, probably you cannot read it, even I cannot. But yeah, we found out some interesting facts about the correlations of words, like Waschstraße, for example, was a highly correlating word with problems with the rain sensor. Like, yeah, if you try to wash a car, or the exchangement of the windshield, yeah, that's where the problems occur. And it always tries to visualize data to get a feeling of what you have. Yeah, that's us, the Text Money group at the knowledge discovery department at the Fraunhofer IAIS. Okay, are there any questions? Okay, nobody?
I have to.
You have to.
It's my job.
Somebody has to. There's one example which everybody, I think, thinks about when it comes to natural language processing. That's how do I understand sarcasm and irony in texts. So, for example, tweets, Facebook posts, whatsoever. So, what is their, let's say, state of the art, or what's impossible right now? So where are the borders of what you can do at the bleeding edge right now, and where does it end?
Okay, it's a good question. Actually, we don't recognize that up to now. Maybe that's another trending topic. Maybe I read a few papers about this the last years, but yeah, it's a very limited support for the recognition of sarcasm and things. Yeah, I think it's hard, but yeah, you have a few features that might help you, like very strong adjectives in the surroundings of these sarcastic areas in the text. But yeah, it's not really accurate, I guess. I don't know the numbers right now, but I think that's really a hard problem. And maybe for some applications this is really relevant. But up to now we didn't have any, because it's like we treat it as noise, and it's the amount of sarcasm in what we had here in the forums with this windshield rain sensor stuff. It's not that much, really. That's the first example, the counter example that always comes then. But actually, I think it's below 5% of the postings. I don't know exactly. Okay, let's get complicated.
If I have several texts, like regarding games, for example, and I want to cluster them, how would you do that? Like you have really a lot of text and you want to cluster them first, and then give a label for this category, for example. For example, it's different to classification because, like, when I know these are strategy games, I already have the label. But if I want to find a common label for them, and I just don't know it before, how would you do that?
Okay, so maybe I try it without the microphone. Maybe is it okay? Do you hear me? Okay. I think that's possible. Like many people do so. That you. If you don't have any training material, I forgot to mention that the algorithms I talked about are mostly supervised algorithms. So that means you need training data to train your algorithms to get a model out of it, and this model you can apply to unlabeled data, so to get the labels, in this case for the classification task. Yes, many people do so. You try to cluster your data to get separate classes in the optimal case, and then you try to find titles for these classes based on very frequent words or phrases or things like that occur in these clusters. Or maybe that could be an approach. I think there's a Solar plugin which does something like that, clustering your search results and giving titles to each cluster. I don't know the name.
Carrot.
The carrot. Yeah, the carrot. That's it. Maybe you have a look at something like that. Maybe that solves your problem.
Right. I had a question about the length of the text. Like, what generally speaking is easier to analyze? Like one big long text, or like thousands of tweets, small text from the same person?
They always relate. That depends on what kind of document is it? What do you want to do with a document? I mean, is it just classification? Then with a longer document, you have a higher probability of finding the features you already know, like known words. You know that a word highly correlates to a certain label. And if you have a high probability of finding this word, then you have a high probability of finding some relevant label assignments. But on the other hand, if you have a very long text, then you might have many different topics being part of this text. So that could confuse the classifier in this stage. So in this application, you could try to separate the document with a clustering algorithm, or just to separate it in every block. And you try to classify each paragraph on its own. So it's just try it out. I mean, there's not a general solution to all these problems. Yeah, but I'd say in general, a longer text is easier to be at least classified as a tweet, for example. If you have many abbreviations in the 140 characters and yeah, many misspelled words, it's always harder to get the topic out of it. I don't know the ordering, so.
I've got a question on detecting sentiments in maybe blog entries or something, to say something about the author, how he thinks about a special theme or something. How are your algorithms about that?
I can say anything about our algorithms, but in general, what I know is, yeah, people do that, and I think it works pretty well. But just on a basic level. I mean, mostly these approaches just try to figure out if it's rather positively the sentiment or rather a negative sentiment in the text. But there are other approaches coming up that try to find very, very, very fine-grained sentiments like fear, like something. I think in the marketing area there are 20 different classes of sentiments, and for me they all look the same. I mean, it's like being embarrassed or being, I don't know the English words for all these slight differences in the meanings of these classes, but for people who produce commercial ads, for example, they want to know what sentiments are triggered at the audience from this commercial ads. I don't know about the quality of these approaches, but I think it's coming up right now, and there's many research going on in this area.
Was there another chat? So please.
I think that there's two things that you didn't much mention that are big in text mining right now. One is the whole idea of linked text. So the web is a huge language resource. It has many links in it. And we can learn about the web, that's obvious. But we can learn about the language that's used on the web as a secondary property. So for instance, there was a great paper by Google recently where they looked at all of the links to Wikipedia, and they did a probabilistic analysis. So they came up then with a probabilistic dictionary of 300 million phrases for things that could refer to the 12 million concepts in English Wikipedia. Okay. And by looking at linkages within Wikipedia, they found other variants of those phrases in 30 other languages. So that's a great example of how the web as a thing can be used to learn about language, which then could be used in other contexts. And these are huge resources that are available, just waiting to do. People are carefully spilling their brains onto the web every moment. A second big trend that I don't think you mentioned was behavioral analysis. You can exhibit what people do. You can say that they continue to be a customer, they paid us money, they bought a product, they disappeared, all of these things. And you can also look at what they say. All of the call centers now record everything that everybody says for legal defense reasons. But many of them now are beginning to analyze that and decode every word that people say. Certainly they have every word they send in an email. They link back where you allow them to what you say on Facebook or Twitter. And so they can produce linkages between behavior and words, which then very closely model they predict behavior, or you can say, given behaviors, what would people say? And these provide nice labeling algorithms as well, because you can take what people say, what they look at, and you can associate things that they would say with content to provide search for them, or you can use it to provide labeling, either direction. So the linkage, the web world and behavioral worlds are two very, very rich sources that make certain kinds of language problems incredibly simple, because you have such a huge amount of data available.
Yeah. Yeah. As you said, many interesting aspects of all this NLP and text mining stuff. I don't know about this Google paper, but it sounds pretty interesting. Yeah. I don't know what to add to that. Yeah, that's true. Everything is linked, and you try to get it as a whole graph. Everything. That's complicated.
And the
But many
linkages
people do.
themselves are the data, not
Yeah.
just the words.
Yes, of course. The links are the data. Yeah.
Something to add? More questions? So, thanks, Hannes. Thank you very much.